Now we're going to talk about inverse functions. So let's say I have some function f of x, and its x value is 2, and I plug that into my function, and it calculates 5, right? So this is my input, and that's my output. An inverse function is when I go in reverse, meaning if I take this 5 and put it in the inverse function rule, it should give me 2. So it's kind of like a function that undoes the previous function. Let's talk about how we label it. So f to the power of -1 of x is the inverse function of f of x. When we look at this, we don't say what I just said. We just literally say the inverse function of x. And in general, the outputs of function f are the inputs of the inverse function. All right, let's look at an example. So I have a table here that is a function, right? It's giving me different x values from -5 to 5, and it's telling me what the outputs of each of those inputs are, right? So the first question is, what is the value of the function of -2? Now notice the question is not about inverses yet. This is just a simple lookup. So if you get confused of like, what am I looking at here? You got to remember that this is f of x. So when they say f of -2, it means I go to x equaling -2, and I figure out what the function is equal to. So f of -2 is 1.5. Now, the next question is slightly different. You're going to notice that it's got a -1 up here in the superscript. And that means it's an inverse function, right? Now, I want you to kind of think of the motion we did here. When we were finding the function, we went to x and found the y. An inverse is the outputs of the function are the inputs of the inverse function. So you're actually just going to go backwards. You're just going to go in the opposite direction. When it wants the inverse of 3, I actually look at this 3 and I go backwards, and I find out that the value that would give me a 3 would be a -5. Do not make the mistake of looking over here. This over here is the function of 3 equals -1. All right, let's do the next question. What is the value of f? Oh, there it is again. So it's asking for an inverse. Now, be careful, because I see a 1 here and I see a 1 here. Well, because it's an inverse, I'm going in the opposite direction. So it's asking me, what x value would give me a 1? So the inverse of 1, I look at this 1, and I go backwards, and I see that it is -1. And these are the final answers. So in f, and you got to be careful that this rule doesn't apply every time. When I was finding a function, I kind of went down, and when I was finding these guys, I went backwards, right? That's why they're called inverses. So inverse functions only exist if there is a 1-to-1 relationship between the inputs and outputs. Now, if you remember, the definition of a function is that for every x, there can only be one y. In other words, for every input, there can only be one predictable output. That's the rule for a normal function. A 1-to-1 function is for every output, there must be only one predictable input. So let's take a look at some examples here. We're going to do it with a graph. So question 1, what is the value of e of 18? Okay, that's very important to realize that they put the names of the function next to it, and you got to make sure you're looking at the right function. The way this is notated here, I can see here that it's e of x. There's no little -1 telling me to do an inverse. So this is showing me that 18 is my x. So for the e function, I go to 18, and I'm going to go look up what the y value is. and it's very clear to me that the y value is 10. So e of 18 is equal to 10. Let's kind of analyze the motion that I did. I looked up the x and I found the y. But with the next question, you're going to notice there's that little -1 again. That means it's doing an inverse. So this is actually kind of giving me the y, and I need to find the x. So it's function O. So I'm going to look at this function, and it told me it wants the inverse of 5. Well, I know what my y is. My y is 5. So I come down here, and I see that my input for that 5 is 4. So the inverse operation of the O function for 5 gives me 4. Okay, so let's analyze the motions once again. When I'm doing a normal function and they give me x, I go up and look up what y is. But when I'm doing an inverse function, I go find the y and then find the x. Because it all comes down to this simple concept. The outputs of function f are the inputs of the inverse function. What is the value of e -1? Oh, that's an inverse function. Okay, so they're not giving me x, they're giving me 5 here. So I'm going over here to 5, and uh-oh, I have a problem because I'm going to get 2 answers, right? On the one hand, if I look up 5, it's giving me 9, and on the other hand, it is giving me -9. So there is an inverse, but it's not an inverse function. So really, I have to say it's undefined. And that's because in order for there to be a inverse function, there must be a 1-to-1 relationship. And this is a great example of a function that doesn't have a 1-to-1 relationship. I have a 5 that can be paired with -9 and 9. Now this is a function, but it's not a 1-to-1 function. So let's write down why it is not a 1-to-1 function, which is what it's asking me to do in question, I guess this is actually question 4. I don't know why I have 2 question 2s here. Oops, I make mistakes too. So let's explain it. So this is what I wrote. This is not a 1-to-1 function because of the coordinate -5, 5. That's -9, 5 is this coordinate. And coordinate 9, 5 show that a y value is paired with 2 x's. And if one y value is paired with 2 x values, that's not 1-to-1. But take a look at this function. Every x value has a unique y value. That's what makes it a function. But also every y value has a unique x value. So that is a 1-to-1. So, and another way of looking at it is in order for it to be a function, it has to pass the vertical line test everywhere. And in order for it to be a 1-to-1 function, it also has to pass the horizontal line test. But on the AP Precalculus exam, they don't want us using the language of horizontal line test and vertical line test. So here is the sentence I came up with. This is a 1-to-1 relation because every x has a unique y value and every y value has a unique x value. So it's a 1-to-1 relationship. I want to summarize this point on a blank sheet of paper. Okay, so let's say we have a graph here with an x and y axis, right? If something's doing this, you know, it's not a function. And the reason why it's not a function is because even though it passes the vertical line test here, right here, it fails the vertical line test here, 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 and here. So this is not a function. But this one, passes every vertical line test that I give it, no matter where I'm looking. There's only one y value for every x value. So this is a function. So a function has to pass the vertical line test. But once again, we will never say that to the person grading our AP exam. So what's a one-to-one function? Well, a one-to-one function is not just a function that passes the vertical line test. It's a function that also passes the horizontal line test. It passes both horizontal and vertical line test. And therefore, it is a one-to-one function. But we don't use this language. So how would I tell the AP grader that this is not a function? It fails the vertical line test. No, 0 credit. This is not a function because there is one x value at least where there are multiple y values paired with it. And that cannot happen in a function. This is a function because every x value has a unique y value. And that's it. This is a one-to-one function because not only does every x value have a unique y value, but every y value has a unique x value. It goes both ways. It's a one-to-one function.